Hello and welcome to EduSathi. Let's move to the topic of arithmetic progressions and geometric progressions. We'll start first with arithmetic progressions. So consider the following series: 3, 6, 9, 12, 15. Now if you look here and if you analyze the numbers that I've written, you look at it that the difference between any two consecutive terms is coming out to be constant. So the difference between the first and the second term is 3. The difference between the second and the third term, between the third and the fourth term, and the fourth and the fifth term is coming out to be a constant difference or a constant thing. So such a series in which the difference between any two consecutive terms is coming out to be constant is known as an arithmetic progression. So in the arithmetic progression, if you take any two consecutive terms, the difference between them would come out to be constant. So if I have to in general write the terms, I will look at the first term. A refers to the first term of the series. Now, if I have to move to the second term, I will have to add a constant difference, thereby making A plus D as the second term. To move to the third term, I'll add another D, so I'll get A plus 2D. To move to the fourth term, I'll have to add another common difference, and therefore the value of the term will become A plus 3D. So in general, the terms are written as A, which is the first term, A plus D, which is the constant difference added to the first term, A plus 2D, A plus 3D, and so on. So in general, if I have to write any term, t nth term, it will be written as A plus n minus 1 into D. A is the first term. To the first term, I will add the constant difference n minus 1 times. For the second term, I am adding it once. For the third term, I am adding it twice. For the fourth term, I am adding it thrice. So n minus 1 is basically the number of jumps that I am taking to reach the nth term from the first term. So it will be A plus n minus 1 into D. Here if you look at it, A denotes the first term and D denotes the common difference. And in general, the term is given as A plus n minus 1 into D. Now let's look at what we understand by the term arithmetic mean. If a series is given to me A, B and C, I will look at it and look at if the terms are in AP, then the difference between any two consecutive terms will come out to be same. B minus A would equal to C minus B would be equal to a constant difference D that I have. So adjusting the terms, I'll get 2B is equal to A plus C, or arithmetic mean is equal to the simple average of A and C. So if I sum up both of them and divide it with the number, what I get is the arithmetic mean of this series. Now for example, the number here which are given are 3, 6, 9, 12 and 15. So if you look here, I can find out the arithmetic mean of this series by adding all the numbers and dividing it with the count. So if I divide it with the count, it is coming out to be 5. So if you just solve this out, it will come out to be equal to 9. A very important thing to remember when we are talking about the AP is the middle term. In an AP, the middle term is equal to the arithmetic mean. So middle term will be your arithmetic mean whenever you are talking about a case of AP. In general, if you have to find arithmetic mean, then you will do sum of observations over number of observations. But if case it is an arithmetic progression, the middle term will always be a arithmetic mean. Now if you look at this series 3, 6, 9, 12, 15. If you just let me go till 18. If you just look at it, look at the sum of the last and the first term. What is it? 21. The sum of the second and the second last term, it is again coming out to be 21. The sum of the third and the third last term, again coming out to be 21. So in case of an AP, the sum of equidistant term. Now this word equidistant is what you need to understand. Equidistant mean when I'm taking the terms which are equal from the front and the back. So first from the front, first from the back, second from the front, second from the back, and so on. Their sum is coming out to be a constant value. The sum is coming out to be a constant value. So what you can do is, whatever is the sum of the first and the last term. Now L is a general notation which is used for last term. That is the sum of all the groups. And how many groups are formed? If there are n numbers, n by 2 groups are formed. So the sum of all the groups will be equal to n by 2 a plus L. So this is the formula that we have. A plus L into n by 2 is the sum of the series of an AP. Now L is the last term which can be written as A plus n minus 1 D. So the last term can be written as A plus n minus 1 D, which is the general formula for it. If I substitute it back, and I'll get the formula as A's will combine to give me 2A plus n minus 1 D, and n by 2 is as such. So this is the formula that we use for the sum of n terms of an AP. A very thing to notice, that the sum of equidistant terms in case of an AP is equal. So if you look at the sum of the first and the last term, that will be equal to the sum of the second and the second last term, n minus 1, second and the second last term, that will be equal to the sum of the third and the third last term, and so on. Let's look at certain examples now. The question is, in the series given below, what will be the 10th term? So the series that is given to you is 357, 363, 369. So what you know is the first term of this series is 357. The common difference that you get for this is coming out to be 6. So what you have to do? You have to find the 10th term. So any term in general is given by A plus n minus 1 into D. So what is it? This is 357 plus n minus 1, which will be 9 into 6. So this will be 357 plus 54, which gives me an answer 411. Or starting from 357, take 9 jumps, and each jump will have a value of 6. Take 9 jumps, each jump will have a value of 6. So total value that you have accumulated in 9 jumps is 54. Added to the first, you will get your answer. The formula to be used is Tn is equal to A plus n minus 1 into D. I hope the question is clear. Let's look at a second question. The second question is, find the number of terms in the series. So I have to find out the value of n. Now what is the first term which is given to you? 201. If you look at it, the common difference which comes out to be is coming out to be 7. And the last term which is given to us is 369. So I can follow the formula. L is equal to A plus n minus 1 into D, or L minus A over D is equal to n minus 1. So the value of n will be equal to L minus A over D plus 1. So if you just subtract the first term from the last term, you will get 168. Divide it with the common difference, which was 7. So if you just solve this thing out, this is coming out to be 24. So the number of terms that you get are 25 for this series. I hope you are able to apply the formulas. Let's look at another question. Find the 16th term of the series. Now a series which is given to you here is a decreasing AP. Decreasing means the first term is 369 and the common difference is actually coming out to be negative. So if you subtract two consecutive terms, that means second term minus the first term, or the third term minus the second term, is coming out to be negative. We'll use the same formula. Everything will be same. There will be no difference that you will have. And what you want? You want the 16th term. So in general, nth term would be given by A plus n minus 1 into D. So this will be 369 plus 15 into minus 7. So 15 into 7 comes out to be 105, which actually has to be subtracted and not added. So the value that you will end up with will be 264. It is a similar question, 16th term, so that means you will make 15 jumps and the value of each jump is minus 7. So subtract it from the first term and you will get your answer of 264. Let's look at another question. The question is find the sum of the sequence. So you have to find the sum of this sequence. Now to find the sum of the sequence, I need to understand the first thing. What is the first term? What is the last term? What is the common difference? If you look at it, the common difference which is coming out to be, it is a positive difference, because if you look at it, the terms are increasing in value. So the positive difference which is coming out to be is coming out to be for 3. You can either do one thing, because this is a very small thing that you have to, and what you have to do is you just have to keep on adding 3 here. So if you add 3, you will get 1. If then you add 3, then you add 3. So this is the sequence that you get. This is an AP of 6 terms. So number of terms are 6. If you look at the sum of the first and the last, second and the second last, and third and the third last. So if you look at it, the value of sum is coming out to be minus 1. There are 6 terms which will form 3 groups, and the sum of each group will be minus 1. So the total sum comes out to be minus 1. This is by using the concept. If you want to use the formula, you can use the formula sum is equal to n by 2 into a plus l, or n by 2 2a plus n minus 1 into d. So this is the formula that you can use in case you want. Now here the problem that you have is you don't have the value of n. So you find out the value of n using Tn is equal to a plus n minus 1 into d, or Tn here that I'll fill will be 7. 7 will be equal to a, the first term that I know, plus n minus 1, which will be 2, n minus 1 is what I have to find out, into d, which is 2. So the value of n that you will get would be 6. You can again put back in the formula and get the same result. Let's look at another question. The question is find the sum of the first 20 term of the sequence. Now it is given to you first 20 term. What is given to you? The first term is 4. The common difference which is there is 2, and the number of terms is given to you as 20. So sum of n terms is given by n by 2, 2a plus n minus 1 into d. I'll just apply the formula simply. 10 into 8 plus 19 into 2. So I'll just apply the formula directly to get to an answer here. So if you just look at the thing, the answer that you'll get will be 460. So if you sum up the first 20 terms of the sequence, they'll sum up to 460 value. Let's look at another question. And the question is, the sum of 3 numbers in AP is 21. So it is given to you that 3 numbers which are in AP. Now, whenever you have to select 3 numbers in AP, I would suggest you to use the numbers like this. A plus D, and A minus D. Instead of taking A plus D, and A plus 2D, you can take the numbers as A plus D, and A minus D. This is still maintaining the same thing. What is the difference between these two numbers? D. What is the difference between these two numbers? D. Now what is given to you? The sum of these numbers is given to you as 21. So it makes very easy for me to find out the middle term. The middle term would come out to be 7. So the terms that you get is 7 minus D, 7 and 7 plus D. And the product of the first and the third number of the sequence is 45. So what is given? 7 minus D into 7 plus D is equal to 45. It is A plus B into A minus B, which will be A square minus B square. So 49 minus D square is equal to 45. You can find out the value of d. So if you just solve it out, the value of d square comes out to be 4. So the value of d that you will get would be plus minus 2. So that means it could be an increasing AP or it could be a decreasing AP. Now I know the middle value is 7. If I take plus 2, I'll get this answer. And if I take minus 2, I'll get this answer. So these are the two APs that you will have. If you look at the answer will be both 1 and 2, because it is possible for me to have an increasing AP or a decreasing AP. I can do this question without even solving by just looking at the option. The sum of all of them should be 21. So if you look at the middle term has to be an arithmetic mean, which comes out to be 7. And the middle term is 7 in all the three cases. Now it is given to you that the product of the first and the last is 45. So if you look here, these are the two options which are matching with both the conditions. So this will be my answer. Now we'll move ahead and we'll understand geometric progressions. If I look at the series 1, 4, 16, 64, 256, and if you look at it, in this series, I am multiplying it with a constant ratio. 1 into 4, 4 into 4, 16 into 4, 64 into 4. So instead of adding a common difference, I am multiplying with a common number. Such a number will be known as common ratio. Now what do you understand by common ratio? That means if you divide any two consecutive terms, they will always give you a common ratio. So an plus 1 over an would be a common ratio. Instead of the difference in the case of an AP, it will be a ratio in the case of a geometric progression. So if I have to write all the terms in terms of the first term will be a, which will be multiplied with r to get to the second term, which will be again multiplied with r, which I'll get r square to get the third term, which will be again multiplied with r to get to the fourth term, again multiplied by r to get to the fifth term. So you will realize that if I have to write any term in general, would be written as first term into r raised to power n minus 1. That means r will be multiplied n minus 1 times with the first term to get to the rth term. First term, second term, r is 1. Third term, r is 2. Fourth term, r is raised to power 3, and so on. So this is how a geometric progression looks like. The consecutive terms have a common ratio in between them instead of a common difference. Here the first term is denoted by a, and the common ratio is given by r. So in general, if I have to write a term, I'll be writing it as ar raised to power n minus 1, or ar raised to power n minus 1. This is how I write the general term of a geometric progression. Now, let's understand the concept of geometric mean. Geometric mean means if A, B, C are in geometric progression, then B is the geometric mean of A and C. So that means if I just look at the thing, B over A will be equal to C over B, because it's a constant ratio thing. B square is equal to AC, or B is equal to square root of A and C. Now what you have is, if there are 3 terms in GP, their middle term will be the geometric mean. If instead of 3 there are 5 terms in GP, the middle term will always be the geometric mean and will be calculated as A B, A into B into D into E, fourth part of that, and will actually be equal to the middle value. So if I look at an example now, so the example that I'll take will be the same thing, 1, 4, 16, 64. Now what you have to understand is, if you multiply the first and the last term, that will be equal to the multiplication of the second and the second last term. So if you make equidistant groups, their product comes out to be equal. The product of equidistant groups is same or is constant. Very, very important thing again. So sum of an AP, if you just have to find out now the sum of a GP, it will not be equal to the thing that we have done in the case of this thing AP. It will be given as the sum of a GP is given as A into r raised to power k minus 1 over r minus 1. This is how the sum of a geometric progression is given at, and this is the sum of k terms of a geometric progression. So in case the GP extends to infinity, then you will have two cases. Whether the common ratio is greater than 1 or less than 1. We call it as mod r greater than 1. Or whether the ratio lies between 1 and minus 1. This will be a very, very important case that you will have. It is segregated into two cases. Now, in the first case, the example that could be looked at is 1, 4, 16, 64, 256. That means your common ratio is greater than 1. That means the successive terms of a GP are increasing. They are in increasing order. Whereas in the second case, if you look at it, it is a decreasing GP. That means the successive terms keep on reducing. Now, if I have given a case of infinite GP, when I'll move to infinity, the terms will become very, very small and could be neglected. Whereas here, the terms would become very, very large and they will contribute to the sum and hence cannot be neglected. So, sum of an infinite GP would be equal to infinity if your common ratio is greater than 1. However, if the common ratio is less than 1, the terms which are closer to infinity would be neglected because they will become very, very small in magnitude and hence will have not much contribution towards the sum. So the formula would be reduced to A over 1 minus R. That is the formula that you have. A over 1 minus R is the formula that I would be using. Now, this formula also is to be used when your R is greater than 1. If your R is less than 1, this formula will be modified as A into 1 minus R raised to power K over 1 minus R. So this is the formula for infinite series. If your R is less than 1, this will be the formula for finite series. That means you can count if R is greater than 1. This formula I will be using if the value of R that you have is greater than 1. Let me use another. Yeah. If the value of R is greater than 1, this is the formula that I would be using. It will be A into 1 minus R raised to power k. Instead of being r minus 1, it will be 1 minus r over 1 minus r. This will be when your r is less than 1. And if your r is greater than 1, it will be this formula that you would be using. Now, whenever you have a case of infinite GP, it will be always the case when your mod r is less than 1 in general, because for the other case, you will not be able to find out your answer. So let's look at some of the questions related to geometric progressions. The first question that we have is, in the series that is given to you, let me just change the color. Yeah. In the series 7, 14, 28, 56, what will be the 10th term? So if you look at it, the first term is 7. The common ratio that you have is 2. 7 into 2 into 2 into 2 and so on. You have to find out the 10th term. So a general term is given by a r raised to power n minus 1. So this will be 7 into 2 raised to power 9. So if you know the value of 2 raised to power 9, 2 raised to power 9 is 512. That will be multiplied with 7 to get to our answer, which will be 3584. This will be the 10th term of this sequence, which is a geometric progression. Let's look at the second question. The question is, find the number of terms in the series into 3 into 3. So that means it is a case of a geometric progression where the first term is 2 and the common ratio is 3 and the last term is given to you as 1458. Now what is it? The last term is a r raised to power n minus 1. So what is the last term? 1458 is equal to a 3 raised to power n minus 1. So if you divide 1458 with 2, what you get is 729. So 729 is 3 raised to power n minus 1. This thing has to be written in the powers of 3. So if you remember, 27 square is 729 and 27 is 3 cube. So this will be 3 cube square. So which will be 3 raised to power 6 is equal to 3 raised to power n minus 1. N minus 1 is equal to 6. The value of n comes out to be 7. So the number of terms in this series comes out to be equal to 7. Let's look at another question. The question is, find the number of terms in this series. Into 3, and so on. So this is the same question that we have in the previous slide. So the answer for this question is 7. I think it's the same question. Yes, it is the same question that we have. Let's look at the fourth question. The question is, insert 3 geometric means between 1 and 81. Geometric means I'm talking about the terms which are in geometric progression. So it will be 1, 81, there will be 3 terms in between. The 5 terms that you get will be a part of a GP. So this will be AR square, AR cube and AR raised to power 4. So what you can look at is this, AR raised to power 4 is 81. The value of A here is 1. So R raised to power 4 comes out to be 81. Now if you just remember, 3 raised to power 4 is actually equal to 81. So the value of R that you get from here is 3. So the first term will be 1, the second term will be 3, the third term will be again into 3, 9, the fourth term will be 27 and the fifth term will be 81. So 3, 9 and 27 will be 3 geometric means between 1 and 81. Now if you look at 1 and 9, just give me 1 second, I'll change the color of the pen here. Now if you look at this value that you have, if you look at 1 and 9, and if you find their geometric mean is 3. If you look at 3 and 27 and find their geometric mean, that is coming out to be 9. If you look at 9 and 81, their geometric mean is coming out to be 27. So if you look between A and AR, the geometric mean is A and AR square. So if you multiply A and AR square and take a square root, what you will get would be AR, which will be their geometric mean. If you take this group now, AR and AR cube, and take their square root, you will get their geometric mean, which will be AR square. So this is how you insert geometric means between the set of values that you have. Let's look at another question. The question is, find the sum of the geometric series. Now whenever you have the sum of geometric series which goes on till infinity, by default you will understand that it will be a sum of infinite GP and your value will be 1 over r this, and mod r will be less than 1. So what is the first term here? It is 1. And what is the value of r? It is half. If you divide this with this, the value is becoming half each time. So what will be the sum of infinite GP? It will be 1 over 1 minus half. So this will be 1 over half, which will be equal to 2. So sum of an infinite series will be equal to 2. I can do this thing because the terms that will be forming will be very, very small and will not contribute to the sum that much. Let's look at the case of harmonic progressions now. If ABC are in AP, if the terms are in AP, I hope you remember what is an AP. It's a constant difference thing. Then their reciprocals, if I look at the terms 2, 4 and 6, they are in AP. Then their reciprocals, if I look at it, 1 by 2, 1 by 4 and 1 by 6 will be in harmonic progression. The terms are in AP, their reciprocals are in HP. So if I take this example now, 3 plus 3, 6, 8, 9. 9, 12, 15. All of them are in AP. Their reciprocals, if I take the reciprocal that are 1 by 3, 1 by 6, 1 by 9, just make a correction, this is 1 by 9, 1 by 12 are in harmonic progression. So, if I have to find out harmonic mean, the harmonic mean would be given by, if ABC are in AP, then the harmonic mean B is given as 2AC over A plus C, or the formula that I'll be using will be 2 over 1 over A plus 1 by B. So if you just, 1 by C. So if you just solve this out, you will get 2AC over A plus C. Now if there are n terms which are given to you and they are not in HP, it is not given to them that the n terms are in HP, but you have to find the harmonic mean. The harmonic mean will be given by n over 1 over A1 plus 1 over A2 plus 1 over A3 plus so on up to 1 over AN. So this is how you find out the harmonic mean. Now I just want to tell you one more thing before leaving this presentation, that arithmetic mean would be given as the sum of observations over the number of observations that you have. For the same set of observations, you can find their geometric mean also. It is not given to you in the question that these numbers are in AP or GP or whatever. The numbers can be anything. You can always find out their arithmetic mean, their geometric mean and their harmonic mean. The only thing that helps us is if the numbers are given to you in AM, middle term will be the arithmetic mean. If the numbers are in AP, the middle term. If the numbers are in GP, middle term will be the geometric mean. If the numbers are in HM, then I can find out the geometric mean, which will be again the middle term. If they are not in AP, GP or HP, still I can find out their value of arithmetic mean, geometric mean and harmonic mean. And a very important thing that I need to understand is arithmetic mean is always greater than equal to geometric mean, always greater than equal to harmonic mean. So this is how the three things are related. In case the numbers are equal, that means if I take A1, A2, A3 all equal, then I will have AM equal to GM equal to HM. But if the numbers are unique, it will be a greater than. AM greater than GM greater than HM. Thank you so much for watching the video. For practice question, move to our website edusathi.com. Have